Okay, welcome back, and we are going to begin our discussion with the other three forces of flight. Let's talk about weight. Weight is something that we deal with every day. It is the Earth's gravitational pull down on objects that gives them weight. Weight always acts from a center point called the center of gravity, and it acts towards the center of the Earth, and it opposes lift. Weight is not a constant. It varies with passengers, cargo, and fuel, and it decreases as fuel is consumed or payload offloaded. If an aircraft weighs 3,000 pounds, well then, initially for takeoff, the aircraft must produce 3,001 pounds of lift to get the aircraft off the ground. Direction is always constant for weight. It's towards the center of the Earth, and it acts through a single point called the center of gravity. So for a 747 that weighs 800,000 pounds, the wings will produce 800,000 pounds of lift for takeoff and sustainable flight. Thrust. Thrust. Forward-acting force opposes drag. Direction of thrust depends on the design. Propulsion systems produce thrust equal to drag in straight and level flight, on accelerated flight. It's interesting enough, a lot of people think that thrust is what causes an airplane to fly. It is not. All thrust allows an aircraft to do is to produce forward motion, which therefore allows the relative wind to start acting upon the wing. And it's actually the wing that produces the lift that allows the aircraft to fly. So all engines are there for is to start the wind flowing around the wings to make an airplane fly. So which one of these airplanes will speed up? Which ones will slow down? I'll let you decide. Engines, either jet or propeller, typically provide the thrust. And like I said, thrust is there to get the airplane moving so the wind starts to flow around the wings, so the wings will produce the lift necessary for flight. Okay, here are some. This is a P-51 Mustang I threw in there because it's just an awesome airplane. What is drag? Well, drag is a mechanical force generated by a solid object moving through the air, or what we call friction. As I said before, for an airplane to take off, lift must initially be greater than weight. But for an airplane to speed up while flying, thrust must initially be greater than drag. And then once you get to that desired speed, as my previous example in the last session, then that's a steady state unaccelerated flight once everything's level. But as your speed is increasing, thrust is overcoming drag at that point. And drag is the force of resistance that the aircraft feels through the air as it moves through it. Now there's two types of drag we're going to get into: parasite and induced drag. Drag is an aerodynamic force that resists forward motion and increases with the square of the speed. Two broad drag classifications. Parasite drag is simply the drag that's created by the aircraft shape. Basically stuff protruding out and all that kind of stuff, rivets and everything. Now, induced drag is the byproduct of lift. The best way I can give you an example of induced drag is if you've ever been driving down the road and you stick your hand out of the car, your hand moves up because of Newton's third laws and Bernoulli's principle, but it also moves back. That backward motion is induced drag. It's the byproduct of lift. And as we can see here, these are wingtip vortices. High pressure seeks low pressure. And where it finds low pressure is at the wing. And as the high pressure comes up to meet the low pressure at the end of the wing, it creates these vortices. And they look like this. Now, the energy that's lost during this is called induced drag. And here's a cool picture of a jet flying through clouds, and as you can see his induced drag back there. Here's C-130. They call this the Flying Angels. When it starts to release its countermeasures, you can see that the wingtip vortices make it look like an angel out of smoke. Here's the wing. This aircraft doesn't go that fast, so what it does is it takes advantage of the thickness of the wing, therefore creating, using Bernoulli's principle to push the wind up faster over the wing, therefore creating more lift that way. Now on this aircraft, it doesn't look like it has very much camber or thickness of a wing at all, because it does use thrust, because it moves a lot faster. So it works on, Bernoulli's principle real good for getting over top of that wing area and producing lift that way. And as you can see, it's got all kinds of airfoils on here. The body is very aerodynamic, okay, and it flies very fast. And you can see just the aerodynamic difference between this airplane and the one before it. Okay, now let's talk about this next airplane. How can an airplane fly upside down? Well, answering how an airplane flies inverted is difficult if you stick with only the curve over the top of the wings that make the air move faster explanation. The curve or the camber of many wings is greater on the top and facilitates the pressure difference between the top and the bottom. However, with no camber difference, basically meaning the top and the bottom had the same curve at all in the wing, pressure difference can be created by tilting the wing into the airflow or using the angle of attack, as such as this aerobatic airplane is. So the wing is symmetrical, and it's using that Newton's third law, or the angle of attack theorem, to produce the wing downward. And this is how this aircraft is flying upside down. Aerobatic airplanes are built to fly upside down, and they have wings whose upper and lower surfaces are equally curved. Wings shaped this way make it easier to fly upside down because they don't need to be tilted as far to produce enough lift. So the question is, can you explain how an airplane flies? Once again, my name is Mike Wagers. I want to thank you very much for taking this course, and I hope you've enjoyed yourself. Have a good day.